Abstract classes and interfaces are a vital part of any complex code hierarchy. But what do they even do?
Imagine sitting in your room, looking at your massive pile of toy vehicles you have collected throughout your lifetime. You say to yourself, "This just will not do. It's time I finally organize them." So you sit down and begin to sort them. Every toy vehicle has its own place depending on its type, color, and if it can fly or sail. But before long, you get confused. So, how do you sort all these different types of vehicles?
Well, it's obvious. You make a computer do it. All you have to do is create an abstract toy vehicle class with child classes and interfaces as well as methods to set a price based on characteristics. But what is an abstract class? An abstract class is just like any other class, however it has the keyword abstract after public in the class header, and it has at least one method that is undefined and considered abstract. See how the abstract part of the class header coincides with the abstract class. An interface is just like an abstract class, with a few small differences. Firstly, an interface in the class header has interface instead of abstract class. Secondly, all methods must be abstract and in the header do not have public or abstract. Thirdly, an interface can have no field variables. And finally, any class can implement as many interfaces as they would like.
So, let's go back to sorting toy vehicles. In our case, there would be an abstract toy vehicle class with subclasses such as car, boat, and plane. The abstract vehicle class would have the abstract method move, because each subclass object would move differently. You would also have interfaces for different things the vehicles can do, such as fly or sail. The subclasses of the toy vehicle class would have their own individual methods as well. So, let's say you get a new toy truck, and you want to put it in the class hierarchy, but you don't have a spot for trucks. What would be the best place to put a truck? A, make it a new interface. B, make it a new subclass of vehicle. C, make a new subclass of car. Or D, make a new subclass of boat. If you said C, you are correct. The best place to put a truck is in a subclass of car because a truck is a type of car.
Let's try another example together. Imagine you've opened a bakery. On your website, you have to group foods based on their characteristics. Some are bread, some are desserts. However, some have things in common, like some things are gluten-free or made of wheat. It's safe to say that food can be an abstract superclass. But what would the subclasses be? A, gluten, sugar-free, and wheat. B, flour, sugar, and baking soda. C, cookies, bread, pastries. Or D, no subclasses. If you said C, you were correct. The best class hierarchy that you can make would include cookies, bread, and pastries as different subclasses.
Although, what would be the best example for an interface? A, gluten, sugar-free, and wheat. B, flour, sugar, and baking soda. C, cookies, bread, and pastries. Or D, no interfaces whatsoever. If you said A, you are correct. Interfaces cannot have any components that aren't abstract, so they are mainly used to further categorize previously existing classes. Sugar-free and gluten are perfect examples of this.
Another question. Say, theoretically, your bakery also serves pizza. Where would you fit in a pizza in your class hierarchy? A, food superclass extending baked good and pizza. B, pizza being a subclass of baked goods. C, pizza being an interface implemented by baked goods. Or D, pizza is the superclass of all other classes. If you said D, you should rewatch this video because the correct answer is A.
Let's try a different example. After have shirts, pants, socks, and jackets, and all sorts of stuff, but you need to organize it somehow. What would be the best way to organize different types of clothing using a series of abstract classes and interfaces? A. Organizing everything by size. B. Organizing everything by what season it would be most often worn in. C. Organizing everything by color. Or D. No organization whatsoever.
The best part about abstract classes is there's no certain way you must organize your classes, although you should use them when you can to avoid messy and unorganized code. Now try to make your own class hierarchy based on whatever way you want to organize your code. This is an open-ended question and there is no correct or incorrect answer. For reference, this is what we came up with.
Now, let's say you have to add in a new restriction regarding if the clothes should be pressed, washed, or not. What would be the best way to add these restrictions in?
Let's try one last example. This one isn't going to help you at all. It's going to be all up to you. Imagine you started working at your local movie theater. The movies have no pattern of organization, and you volunteer to organize how the theaters are laid out. Create a class hierarchy however you'd like to organize the movies in the theater. Good luck. Just to recap what we've learned today, we've learned how to use abstract classes and interfaces to better organize our code, and the basics of how sub and superclasses work as well.
For more help, visit www.docs.oracle.com/java.se/tutorial/landl/abstract.html or www.geeksforgeeks.org/abstract-classes-in-java. Now you've organized your toys and lost two separate jobs, you now know how to use abstract classes and interfaces.